We're going to solve May 2024 paper 2 question number 7. A lot of students faced problem in this particular question. So let's get into it. The figure 1 shows a right triangular prism ABCDEF. The base ABCD is on a horizontal plane where CF and DE is equal to 40 centimeters. So this is 40 and this is 40. And EF and DC and AB is 100 centimeter. This is 100. This is 100. This is also 100. And angle FBC is 30, as you can see. So the point H lies on the line BF such that BH is equal to 57.5. So this is the line BF and this is BH. BH is 57.5. Question says show that EH is equal to 102.5 centimeter. This is EH. So this is right angle triangle because AEFB is a rectangle and all the corners of rectangle are 90 degrees. So let's draw the triangle EFH where EF is 100. So to find HF we need to find the length of BF. We can find the length of BF using this triangle. As this is a right angle triangle, we can use sine 30 is opposite by hypotenuse. BF is equal to 40 by sine 30, which is 80 centimeters. So BF is 80 centimeter, and to find HF, we can subtract from 80 57.5 and we get 22.5. So here HF is 22.5. As said earlier, this is a right angle triangle. So we can use the Pythagoras theorem, which is EH squared is equal to EF squared plus HF squared. And we get the answer to be 102.5 centimeter. Calculated in degrees to see significant figure, the angle EHD. So we need to find, this is EHD. We need to find this angle. As we know, DE is 40 and EH is what is we proved. So as you can see, this is not a right angle triangle. So we need to find all the sides. We need to find DH as well and use cosine rule. To find DH, we can draw a vertical line from H to BC and name it X. As we know, BH is 57.5. We can use that to find the length of HX and draw a triangle here and find the length of DH. But to find the length of DH, we need to find the length of DX. We could find the length of dx using this triangle here. So it is tricky. Let's just do it slowly, part by part. Let's start by drawing the triangle PHX. We can use sine rule to find HX. Sine 30 is HX. HX is 28.75 centimeter. So let's just draw this triangle first, DHX, and see what we need to do. You know, HX is 28.75. We need this. To find this, we also need this. And we can find DX using this triangle here. This is 90 degree because ABCD is a rectangle and all the corners of rectangle are 90 degree. So let's draw that. DCX, you know, DC is 100 and we need this side here. To find this side, we also need this side, and we can find CX using this whole BC, and then we find BX and subtract that to find XC. So we can find BC here using Pythagoras theorem, as we know that BF is 80. So BC is, and we get BC to be 40 root 3. And we can find BX using this, as we know HX is 28.75. So BX is 40 root 3 minus 49.796, which gives us 19.486 here. So this is 19.486. And we can use Pythagoras theorem to find dx. We can again use Pythagoras theorem to find dh here, as this is also a 90-degree triangle. So this is 105.5 centimeters. So now that we got all the sides of the triangle EHD, we can use cosine rule. Square of one adjacent side plus the square of other adjacent side minus the square of opposite side by 2 into, and then we inverse the cos here and find the angle EH to be 22.06 degree. And since the question said to give the answer in 3 significant figures, so this is 22.1 degree. That's how we get done with question number 7. This was one of the trickiest question of this paper.